Hello ladies and gentlemen, welcome to the part number 6 of this SDL programming tutorial. This is Mike, and I'm going to keep taking you through this building blocks approach to creating a game, or creating a framework for the game. I've probably mentioned this in like the first video, but I'm just gonna reiterate it again. This tutorial is different from like some of the other tutorials that you might find online. And the difference is that, at least that I can see, is that this is a bottom-up approach. The reason I kind of prefer it is because a lot of people tend to do what's called kind of top-down kind of programming, where they go on and they start writing right away the main program, the main class, and then they put a bunch of functions that are not yet defined, and then hoping they're going to get defined sometime later, and tell you to just assume that they work, and then later you find out what the purpose for that function was, but you keep following along blindly, and you are kind of just, assuming that something would work. Right now, what I've shown you, and what I keep showing you, there's no mystery in any of this stuff. The only mystery maybe is how it's going to incorporate into the main program, but you will see that clearly as soon as we start writing the main program. So when I go into the main program and I was like, well, okay, so we're going to take this class, C event, and we're going to do this with it, and you're going to right away know what C event means because you've written that class, you've seen it being written. You can go back to it, look at every line. You know what function does what. So this is the bottom-up approach. There's, some people prefer one approach, the other. I prefer this particular approach for me personally. I don't like when people do the top-down because it obscures what's going to happen. How is it going to happen? Actually, it doesn't obscure the what, it obscures the how. So, with that being said, here we are back at this, this program, and we're going to step back. We just did the C event class, which is, C surface class. We just did the C surface class, which will help us work with surfaces. Okay, so now we have this on load here. Here it is. I make it a little bit bigger. We have on load, we have on draw, and we have set transparent color, which is really all we need from the surface. That makes it a lot simpler. Makes these things a lot simpler. So what we're going to do now is we're going to get back and remember 2 videos before where we were working on the C app state class. Let me bring that back up. Actually, I'm going to close both of these classes, both of these class files, and I want to bring back the C app state H and C app state CPP. If you remember, I told you this was an absolute virtual class. It's got these 4 functions that are what are called pure virtual, which means they have to be defined in the overriding class. And this class right now by itself makes no sense. In fact, you can't, I don't even believe that the compiler will let you instantiate this class with all these functions being pure virtual, because they have to be defined somehow. They have to be defined somewhere. So they're going to be defined in the overriding class. Also, do remember that this is inheriting from C event. Even though it looks like it's pointless right now, you will see that it's not pointless, because C event is where all of our events get described. And so what's going to happen is we're going to create more classes. Right now, you're going to see we're going to create some app states which are going to be derivative from this C app state, this generic C app state. And these classes are going to in turn inherit from C event also, which will allow them to process all kinds of events inside those classes. So we're not going to do anything with C event here, but we are going to do something with C event when we override the C app state. So, which is about right now, actually. So let me go ahead and zoom this in again. I keep forgetting to do this. I hope you guys are not mad at me for the small print. It's hard for me because I can see it perfectly on my screen, but I keep forgetting that for the video I should make the font a little bigger. But I'm trying to fit a lot of things on my screen here. So, and this is, a rather small window actually. It's not my whole screen, obviously. It's my recording window. So this is what we do. We have C app state. Now, this is how it's all going to come together eventually. We're going to have the one class, which is going to be called app state manager. It's going to manage these application states. And the reason why we have this generic C app state is because it's going to refer to all of them as a C app state. This is what polymorphism is all about. It's going to treat any application state as if it's just a C app state. Okay, even though it could be a it could be a C app state intro, it could be C app state actual game. Any of the C app states are going to be treated the same. They're going to be just basically the app state manager is going to pass messages between the app states. And so, excuse me again. Long class today. My voice is kind of going bad. So that's what's going to happen. We're going to have an app state manager that's going to manage a bunch of app states for us, but not the actual app states, the whatever's derived from the C app state. So we're going to do that right now. We're going to create two classes which are going to be identical, actually. We're not going to make any changes to them. We're going to make two identical classes which are going to be both, but they are going to have different names. They're going to be different app states. We're going to call one of them intro and the other one game, just for the heck of it. That's the names, all right, that we're going to give them. So right here, I'm going to leave these two open, and I'm going to go to, just like I do all the time, create new file, create new header, and we're going to name this one C app state intro. And we're going to edit to both debug and release. Now, this class, and I'm going to start writing it right now. I'm going to start writing class C app state intro. Obviously inheriting from C app state, as we've previously discussed. Okay, so now that I've inherited from C app state, I just basically obligated myself to override every one of these functions. You understand? I have to either redeclare them as virtual, which means something else was going to have to override them later on, or I have to override them. I have no choice in the matter. I cannot just leave them hanging. I have to override these functions, these apps, these perfect virtuals. I mean these pure virtuals. I don't have to override this destructor, but I do have to override all of these equal zeros. So in fact, why don't I just go ahead and copy these from here, Control C, and paste them into here, right? So, you know, I'm gonna just go ahead and set that to public, and I'm going to get rid of the virtual, and I'm gonna get rid of the equal zero, right? Because in this class, they actually are going to have a body. All of these functions are going to have a body. They're not going to be virtual. They're virtual in here because that's where, you know, we're overriding these. But these are the actual concrete functions. They're not virtual. They're going to have actual body to them. Okay? Now, let me talk to you about a very important design pattern. As I told you before, classes have different design patterns. There are some classes that are different from others. Not just in the sense that, like, they hold different information, but as I told you before, there are some classes which are adapter classes. There are some utility classes, which in adapter class, that would be like the C event, right? And the utility class would be like C surface, where all we have is a static functions, right? Public static functions. We have a virtual class, which is like a class that contains only virtual functions. And now we finally have another type of class, which is called singleton. Okay, we're about to create something called singleton. You may know already what it is. If you do, great. If you don't, I'm here to explain it to you. Just one moment. I see that my character there is going beyond the 80 character mark, so I'm just going to go ahead and fix that. Right. So, as I was saying, we're going to create a new type of class. It's called a singleton class. Now, what is a singleton class? A singleton class is a class where there is an instance of a class, a variable of a class, but there's only one. Singleton. That means that the class only may have one variable of its type. No more, no less. Okay, you cannot create your own variables of this type. You can't just go new game state intro, you know, or just have game state intro you can't have game state intro variable. Okay, so this is what we're gonna do. we can actually define a private constructor to prevent it from being instantiated if we want to be, paranoid. We don't have to, but it's, it's something that you could do. So CApp state intro. So here it is. How do we accomplish the singleton model? Well, the singleton is usually accomplished. There's actually several different ways. If you read a book on design patterns, there are several ways of accomplishing the idea of a singleton, because singleton is just an idea. You understand? There's no one right way to do the singleton. There is, however, a very common way, which I would say the most common way. Maybe it's not, maybe it is, I don't know, but this is what I normally do, and this is what a lot of people I know normally do to create a singleton class. When you create a singleton class, what you do is you go into here, you create a private static variable of the class type itself. So CApp state intro. Okay? Oh, sorry, I didn't mean that. I meant this. And I'm going to call it instance. Right? Now, look what's happening. This class is containing a member of itself. It's containing a variable of type itself. This is perfectly allowed, and this is now a variable. There's a variable of this class now inside the class itself, which means that whenever this gets created, it can use a private constructor that we're going to have. So right here, we might as well go ahead and make it right now. We're going to make a CApp state intro constructor, right? Okay, so that's what's going to be what's going to be there, this constructor. And now, since we have a static variable, look, static variable in this case means the same as a static function. It's private though, which means we will need some kind of a method or a function to get to it. But the fact that it's static means that this instance variable is independent of class variables. You understand? So this variable right here, this variable of the class type, is not actually a member of the class itself, not a variable, not an instance variable of the class. It's just it's a member. I know I'm not explaining this very well. This is a static variable which can be accessed from anywhere. Okay, so as long as this class exists, it will have that static variable as its, you can access it because it has that static member. It is private though, so you would have to have an additional function right here, which will be like get instance, and what it'll do is it'll return a pointer to CApp state intro. So just like that, CApp state intro, and it's a pointer. We'll call it get instance. And this function will give us a pointer to this instance, and that will allow us to manipulate the class. That will allow us to do whatever it is we want with the class. So this is going to be the only, look again, look what's happening here. This is a private constructor, right? It's a constructor, but it's private. What does it mean? It means that in my main program, I simply cannot do this. CApp state intro just like that. I cannot declare a variable of CApp state intro, even though there is a class called CApp state intro, but I cannot declare a variable called CApp state intro because its constructor has been purposefully put into the private section. So when you try to do that, it'll tell you CApp state intro cannot be instantiated, constructor is private. However, the CApp state intro, through get instance, you can actually get to this variable right here, which has already been created, and you can do whatever with it. So when the program runs, basically when everything's compiled and runs, this variable already exists, and you can get to it using this get instance method, this get instance function. Okay, but you cannot create your own CApp state intro. It's already been created. There's the only one. I hope that I'm explaining this good now. The idea is for you. So this is a typical singleton class, right? And these functions all get copied from the CApp state, and all we have new is the get instance and the actual instance, and the constructor has been made private. So that's it. Okay, that's it. Now, what we're gonna do, and I know I usually split this across two videos, but what the hell, this is going to be nice and quick and easy now. We are going to go and make a CPP file for this class, and once again we go through the same familiar motions. C app state intro, except now it's CPP. That's going to be automatically added. Now, when you have a static, you know what? Let me close all of these so they don't get in our way. When you have a static variable inside a class, okay, which is what this is a static variable, you need to also include that in your CPP file as a definition. Let me show you how to do that. First of all, you need to not forget to include CApp state intro, right? To ensure that this CPP file is linked to that H file. Now, the name of the variable is instance. Okay, so this is a bit of a weird syntax for those of you who haven't done this before. But what you do is, as you know, that when you declare members of, like if you declare functions that are in the class CApp state intro, you would normally do this: CApp state intro, and then colon colon, and then a function name, right? Well, you do the same with variables, and their type is actually like you would write a return type. So what I'm getting at is you would write this: CApp state intro, CApp state intro instance. Okay, look, this is what I did. This right here, these two things, they repeat, but they mean different things. This means that the name instance should be found inside the CApp state intro class. This means that variable C instance, which should be found inside the CApp state intro class, is also of CApp state intro type. Okay, so yeah, I could have wrote like int if this was an int variable, but it is a CApp state intro, which is, it's the same class, it's the same type as the class itself. So I end up writing like that. That's what you want to write here. Okay, that's it. That's what you want to write. No function, nothing, just like that, one line and terminated. Now, the next thing you want to do is you have a constructor there, so you might as well go ahead and declare that. Define it, I mean, you will define it. And the constructor is going to be blank as of right now. We're just making these generic. We're gonna introduce functionality to them later. Now, all of these functions right here, all of these functions are gonna have to be defined in here. So again, same thing, void CApp state intro on activate and blank body. Notice that I'm no longer putting these brackets on the same line like we did in C event, because we are actually going to put something in here. That's the idea. The idea is for something to actually go in there. Maybe not right now, but it will eventually. Now, void CApp state intro on loop. Void CApp state, CApp state intro on render. And let's not forget that there was an actual parameter there. And that. And finally, void CApp state intro on deactivate. There you go. So all these functions are going to be left blank until the better times. However, there's one function there isn't going to stay blank, and that's the get instance. So CApp state intro. Now here's another one of those situations where you write that down to indicate what it returns, and it returns a CApp state intro pointer. And then once again you use a CApp state intro as the name qualifier and get instance, just like that. And what it will return is it will return the address of instance. Okay. Oh, and by the way, if we didn't do this, let me check if we did. Oh, sure we didn't, of course. This needs to be static. Why? Because only static functions, like you have to have a static function to access a static variable. I mean, that's not exactly true. You can have a regular function access a static variable, but because we're not instantiating this class, I mean, you really are, I mean, if you want to, this is a singleton. So if I didn't make this static, I simply wouldn't be able to call it, and because I wouldn't be able to call it, I wouldn't be able to get to the instance anyway. So it's like it's gonna be a catch-22. You know what I mean? Like I can't get to the instance because I need this function, but this function is a member of this, so I have to get to this to get to this. You understand? But because it's static, that means, and it's public and it's static. Now I can call getInstance on this class whenever I want and get a pointer to this guy, which will then allow me to refer to that, and that, because these are all member functions. These are all instance functions. They're not static functions. So in order to get to them, I have to get a hold of a specific instance. And here, I will return the pointer to it. I'm not going to return the instance itself by value. I'm just going to return a pointer to it so that later that pointer can be manipulated. Okay? All right. So now what I'm going to do is something very, very, well, not strange, just silly. I am going to copy this class almost in its entirety and make a whole another class. So honestly, I'm going to do a lot of copy and pasting right now. I'm just going to make another whole file and make it and call this time a app state game. So it'd be like C app state game. And let's actually, I keep shortening these. Let's just shorten them to H. Okay, and actually let's go to right here and do that to that as well, because I really don't like these long header guards that code blocks is doing. Of course, that's just a personal preference. You can leave them there if you'd like. So C app state game. Now what I'm gonna do is I'm gonna go to C app state intro. I'm gonna copy this entire thing, and I'm simply gonna just slap it right here. The only thing I'm gonna change is the name intro to game. Every time I see C app state intro, I'm going to change it to game. That's it. That's all I'm going to do. Let's copy this class exactly. And also, let's copy the CPP file exactly as well. So, new file, C++ source, C app state game. Again, we add it to both targets. We finish, and we go right here to the C app state intro.cpp, copy the entire thing, select all, copy all, and then now just change every time you see intro, change to game. Alright, so just like that. Like that. In fact, let me just go ahead and copy the word game and be totally lazy. And change that to game, 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 and both of these to game. That's it. Now the moment of truth. I'm going to compile all of these. Ooh, we got errors, errors, errors. Just lots and lots of errors. Let's see what those are, huh? Okay, expected class name before this token. Let's see. Oh, yes. We have never included C app state. Okay, so we say right there public C app state, but the C app state is never included. And was it in here? No, it's not. So we do need to do that. So we need to include C app state in there and include C app state in here. Okay. Now I see that these classes both also don't include SDL. So, but that's not that important because they inherit from C event eventually, and that includes SDL. So let me see if this works now. Oh wow, I'm doing the wrong file. Okay, compile current file. Perfect. And compile current file. Perfect. Alright, so both files compile. Now, these are identical classes, guys. Right now, these are absolutely identical classes. They just have different names. This one's called AppStateGame. This one's called AppStateIntro. Even this variable instance is the same in both of them, except this one it's of type intro, and in this one it's of type game. Alright, so we have two absolutely identical classes in all respects. They both have AppStateIntro get instance, which will return an instance. Actually, they have get instance. Here it's the other class name, but still the same function. These functions both do absolutely nothing right now. Right, as you can see, nothing on activate, nothing on loop, nothing on render, nothing on deactivate. But they do serve their purpose. We are going to create next a CAppState manager, which is going to switch between the states for us. And so I needed to create at least two to demonstrate that. Until then, I will see you in part 7. As usual, have a great day, evening, whichever time of day it is that you're watching, and I will see you very, very soon. Goodbye.